Hello and welcome to this video that is a question paper taken from the Mathsaurus website, and this goes through integration for AS level for finding areas. So question 1 is this question that shows a graph of a quadratic function. The graph crosses the axes at the point -1, 0, 0, -4 and 2, 0. Find the area of the finite region bounded by the curve and the x-axis. So for this equation we're going to have a quadratic, so we know that the quadratic must have the form of ax squared plus bx plus c is equal to y, as all quadratic functions do. And we first identify some of the terms that should be there. So first of all we can find what the so there's several ways about we can do this one. One way we could do this is to plug in the coordinates that we know to set up a series of simultaneous equations. So the first thing we have here is when x is -1, y is equal to 0, then we can substitute that in. So it's a times -1 squared plus b times -1 plus c is equal to 0. So that would give -1 squared is 1, so that will give a minus b plus c equal to 0 as equation 1. Then the next question we have, or the next point that we have, is going to be x is equal to 0, y is equal to -4. So from here we're going to say that this is going to be a times 0 squared plus b times 0 plus c is equal to -4. Again, you could see this one from the fact that c is always where the y-intercept is. So the y-intercept is when x is equal to 0. So here c is equal to -4. And this means that we can also add in something for equation 1. We can say a minus b minus 4 is equal to 0. So a minus b is equal to 4. So we can improve equation 1 that we created there. And then the next one we have is 2, 0. So we could say that this is going to be a times 2 squared plus b times 2. And c is now -4, so -4 is equal to 0. And therefore we can say that this is 4a plus 2b is equal to 4. And we've got a minus b is equal to 4 as well. So from here we can then substitute into our equation, and so into our calculator. So we go into menu, then equation of function, and simultaneous equations with two unknowns. We're going to take x as a and b as y, so 4a plus 2b is equal to 4, and then x is going to be 1 minus 1 is equal to 4, and that gives a value where on the calculator x is equal to 2, so this will be a is equal to 2 and b is equal to -2. So therefore we can then substitute that into our main equation and get an equation of 2x squared minus 2x minus 4 is equal to 0. From here we want to find the area of the finite region bounded by the curve and the x-axis. So we want to find this area here. So to find this area we're going to integrate between the limits, and the lowest number that we have is -1. And the highest number we're crossing is at 2. So -1 on the x, again, we just look at the x for limits, and we're going to plug in our equation, so it's 2x squared minus 2x minus 4 dx. We then integrate, so raise the power by 1, so 2x cubed divided by the new power, so in this case 3, do the same again, so raise the power by 1 to 2, divide by the new power, raise 1 by power by 1, so it's going to be go from x to power 0 to x, we add on the x term, between 2 and -1. Again, no need for any limits. No need for, constant. We need limits, no constant, because we have limits. And then we're going to plug in our numbers. So 2 times 2 cubed over 3 minus 2 times 2 squared over 2 minus 4 times 2. And then we're going to subtract our second one, so 2 times -1 cubed over 3 minus 2 times -1 squared over 2 minus 4 times -1. Substituting this into our calculator. So 2 times 2 all cubed over 3 minus 2 times 2 squared over 2 minus 4 times 2 gives you -20 over 3. Again, you can always check your answer by directly substituting into your integration, but you should show your full workings out when you do this. So then the next step we've got is 2 times minus 1 cubed over 3 minus 2 times minus 1 squared, and then minus 4 times minus 1. Plugging this into calculator gives you a minus 7 over 3. So then from here, this gives an answer of minus 27 over 3. Now, because we're looking for an area here, and because it's under the curve, that is fine, because that gives a negative, it will give a negative area if it's under the curve. So we can say that our area is essentially equal to 27 over 3. And that is the end of this question. This is question 15 from the AS 2018 paper. Figure 4 shows a sketch of part of the curve C with equation y equals 32 over x squared plus 3x minus 8, where x is greater than 0. The point 46 lies on C, and the line L is normal to C at the point P. The region R, shown shaded in figure 4, is bounded by the line, the curve, and the line with the equation x equals 2 and the x-axis. Show that the area of R is 46. So we can see here we've got quite a busy question with lots going on. So it's very important that we break down exactly what we need to find, so you've got a plan of action for when you're doing the question, because it's very easy to get quickly lost and not remember what the next part is. So doing a quick, especially for these 8, 10, 12 mark questions, make sure you can write a little checklist of what you need to do. So the first things first is we know, what do we know? So we know that we're trying to find R, and we know that that's going to be under the curve here. So we know P, that's given to us, so that's 4, 6. So one thing that we can do straight away is that we can integrate under the curve, and that's going to find our area between 2 and 4. So step 1 we could do is integrate C between 2 and 4, and that will give us our first step. Then the next thing then is we need to find our line. So we know that it's normal to C. So the next thing therefore then is to find the line, we need to get it in the form y equals mx plus c. So in order to get to that, we first of all need to find what c and the gradient is. As we know that the line is normal to c, we can then find the gradient of c and then do the negative reciprocal. So the first thing we're going to do is we're going to differentiate c and find the gradient at p, and then we're going to find the normal gradient and sub in p to find L. Remember, L is in the form yx equals mx plus c. Once we found that, we're looking to integrate this, but we don't know where it crosses the axis. So then step number 4 is to find where L crosses the x-axis. And then number 5, we're going to integrate below L between 4 and the point at 4, so what we've just found. And then number 6, we need to add it together. So the last step again, to think about what we need to find. So at number 6, we need to add the areas together. So once you've got that, you've got a plan of action. So then it makes it easy, broken down the question into the parts. Yes, it might take a couple of minutes to write this down and work out what you need to do, but once you've got that, it should be a bit quicker than half stopping halfway through. So the first thing we're going to do is integrate c between 2 and 4. So we know that the curve that we're given is y is equal to 32 over x squared plus 3x minus 8. So in this situation, we want to integrate between 2 and 4. I'm going to rewrite this equation and get rid of the power below, because that makes it easier for me to integrate and differentiate. So by rewriting this power as x to the power of minus 2, because it's in the denominator, it's going to make it maybe potentially a little bit quicker and less likely for me to make mistakes when I'm integrating. Again, this is an optional part that you don't need to do. So first of all, we're going to integrate our curve. Again, you can plug it straight into your calculator to get an answer, but you do need to show that you know what you're doing, so you have to write out the method. So we're going to raise the power by 1, so minus 2 plus 1 is minus 1, divide by the new power. Then we do the same again, so raise the power by 1, divide by the new power, and then we do the same again. Raise the power 1, divide by the new power, so we get 32x power minus 1 over minus 1, 3 over 2x squared, and minus 8x between 4 and 2. From here we're going to substitute in our answers, so it's going to be minus 32 to 4 to the power of minus 1, plus 3 times 4 squared over 2 minus 8 times 4. And then we're going to close, put that in brackets, and then we're going to subtract bracket 32 to the power of minus 1 plus 3 times 2 squared over 2 minus 8 times 2. And then we're going to plug it in. Again, take this steady, don't need to plug it in, just do it to ensure you get the full marks. Ensure you just do it term by term into calculator, and then write out your answers through here. So it's going to be minus 16 and then minus, plug in your answer here, so 2, 2 and 2, and it's going to be minus 26. So we're going to end up with an answer of minus 16 minus 26, which is just 16, minus 16 plus 26, which is 10. So the first part we have here, the area under the curve, is going to equal 10. Between 2 and 4 is 10. The next step then is we're going to differentiate C and find the gradient at P. So we're going to find dy dx. So we differentiate this, so dy dx is equal to, so when we differentiate, we multiply by the old power, so 32 to x to the power minus 2, we're going to multiply that by minus 2, that's our old power, so it's going to be 64, then we're going to reduce this power by 1, so it's going to go to x to the power of minus 3, remember minus 2 minus 1 is minus 3, then we're going to do the same again, so 3x will go straight to 3, and then minus 8 goes to 0. So then from here we've got this function, so we want to find, we got the dy dx, we now put a substitute in our x term to find the gradients at this point. So we find the gradient when x is equal to minus 4, so dy dx at x equals minus 4 is equal to minus 64, 4 to the power of minus 3 plus 3. Plugging this into your calculator again, just directly substitute in the numbers and we get an answer of 2. So dy dx is equal to 2, so the gradient at that point is 2. So that gives us our part 2 of the answer, and part 3 is find the normal gradient and sub into P to find L. So to find the normal gradient, m is equal to minus 1 over dy dx. So plugging that in, it's going to be minus 1 over 2, so our gradient of our line is going to be minus a half. So we know that the line L is going to be y equals mx plus c, so we're finding again, goal here is to find this line L. So then from here we're going to substitute in point P because we know that it travels through point P. And again we wrote that in our method. So point P is going to be 4, 6. So we know that x is equal to 4, y is equal to 6. So it's going to be 6 is equal to minus a half times 4 plus c. Plugging this in, we're going to get the following. So it's going to be 6. So minus half times 4 would do it a little slower, so it's going to be minus 2 plus c, so c is going to equal 8 at this point. So then from here, we can then plug in, we've got everything we need, we know, so it's going to be y, we know m is minus a half x, and we know c is 8. And that gives us our line, so that's part 3 done. And then for part 4, we need to find where it crosses the axis, so from here, question 4, for part 4, we're going to substitute in when y equals 0. So when y equals 0, so the reason why is because when it crosses the x-axis, at this point here, we know that y must be 0. So therefore, we're going to substitute that in. It's going to be 0 is equal to minus a half x plus 8. And then it's minus 8 equals minus a half x. And then we're going to times both sides by 2 to get, by minus 2 to get 16 is equal to x. So we know that at 16, 0 is where the line of this crosses the x-axis. So we know the line here is 16. Now question 5, you've got two choices here. You can integrate it, so you can integrate the line that we just found, so y equals minus half x plus 8. And the limits that we're going to integrate it between are between 4 and 16. However, there is a shorter method because this is the same as a right angle triangle. So our right angle triangle here is going to be down at P, across to 6, down to 4, down to the x-axis, across the x-axis and along. We can simply use the, and we also know that this is at 6. So therefore we can just use the area of the triangle. So it's going to be 6 on this one. 16 minus 4 is 12. And therefore we can then use the area of the triangle, which is a half times base times height, so half times 6 times 12, which gives an answer of 36. Again, you can also integrate it, so by integrating it, you are going to get the following. So minus a half x squared over 2 plus 8x between 16 and 4. So this will go to x squared over quarter plus 8x between 16 and 4. And then you just plug your numbers in, so it's going to be minus 16 squared over 4 plus 8 times 16. And then we're going to subtract minus 4 squared over 4 plus 8 times 4. And again, if you plug those into your calculator, you should get the same answer of 36. We'll just double check. 16 squared over 4 plus 8 times 16 minus 4 squared over 4 plus 8 times 4. And we get an answer of 36 as well. So then the last step that we have is we need to show that the area is 46, so we're going to add the areas together. So to add the areas together, we're going to have, so let's say area 1 is equal to 10, which is what we found back at the start when we integrated the curve, and then area 2 is equal to 36. So the area in total is equal to 10 plus 36, which is equal to 46 as requested in the answer. And that's the end of this question. Next question we have question 15. Figure 4 shows a sketch of the curve C with the equation y equals 5x to the power 3 over 2 minus 9x plus 11. The point P has the coordinates 4 and 15, and line L is tangent to C at the point P. The region shown shaded in figure 4 is bounded by the curve C, line L and y-axis. Show that the area of R is 24, making your method clear. So we want to find what R is. So we know what point P is. So again, how do we go about approaching this one? So here we've first got a curve that we know that we're going to find at least part. We're going to use part of the area under, and it's bounded by the curve line L and y-axis. So when we're going to integrate in the curve, we're going to integrate between 0 and P. P has the coordinates 4, 15, so it's 4 on the x and 15 on the y. So the first thing we can do is we can integrate the curve between 0 and 4. Now this question is different from the previous question in terms of that we have a line again, so we're going to find the equation of a line. First of all, it's a tangent, so we approach it slightly differently, and secondly is that we need to subtract the area here because the area under the line we're not interested in. So number 2, we know that the line is tangent to C, so therefore we know what the gradient is, but it also means we have to differentiate the curve. So we're going to differentiate our curve. So differentiate C and find gradient at P. And then we're going to do the same in terms of we're going to find the line. So it's a tangent. So it's the tangent of the line, so m is equal to dy dx. And then we're going to sub in P to find L in the form y equals mx plus c. So that's our next step. So we then need to integrate under that line. So we're going to integrate there, and therefore we need to find where it crosses the x-axis. So find where it crosses the x-axis. So that's going to sub in y equals 0. And then number 5, notice that we've got this little extra area here. So essentially this is what we'll call area 1, that's our total goal. And that includes the area under the curve and the area, but subtracted away with the area number 2. But we also have area 3 that's also shaded. In that case, we need to integrate or find the area. So we need to integrate the line between 0 and the point that we found in 4, or step 4. And then number 6, don't forget to add areas. So one step we've missed though is that we haven't found, so find where it crosses the x-axis, we found where it's 0, and that one. So that finds a little curve. We did forget to find area 2, so before we add the areas together, we also need to So find the area between 0 and that one, and then number 6 is that we're going to find the area between this part here, what we find in number 4, and the and 4, because that's where point P is. Then we're going to for number 7, we're going to do the area under the curve, subtract the area found in part 6, and then we're going to do question 8. We're going to do we're going to add the area in 5 and the area in step 7. So it's a long question, this one, lots of adding sort of things. Again, by writing out what you're doing, again, you may not be able to write all of this in one go, but it helps you structure your answer so you know where you're heading with each step. So let's start again. Back in question 1, integrate the curve between 0 and 4. So we're going to integrate this, so 4 and 0, and it's going to be 5x to the power 3 over 2 minus 9x plus 11 dx. Raise the power by 1, divide by the new power, so it's going to be 5x. Raise the power by 1, so 3 over 2 plus 1 is 5 over 2, divided by 5 over 2, minus 9x squared, so raise the power by 1, divide by the new power, and then 11x between 4 and 0. We can tidy this up just to make it a little bit easier, so we can bring the 2 up to the front, 5 times 2, and we can divide by the 5, so that's going to give you just 2x 5 over 2 minus 9 over 2x squared plus 11x between 4 and 0. Now this one's nice because it's with 0, so therefore we can essentially ignore one of the subtraction part, because so it's 2 times 4 to the power 5 over 2 minus 9 over 2 4 to the power 4 squared plus 11 times 4, and then this time it's just going to be subtract 0 because they all have an x term, which if we substitute that into 0 it will disappear. So here we can just plug it in, so it's 2 to the power 4 5 over 2 minus 9 over 2 4 squared plus 11 times 4, which gives you an answer of 36. So that's your first step that we've done, so that's your area in 1. So that's the whole curve. So the next thing then is we need to differentiate C and find the gradient at P. So when we differentiate this one, so we know y is equal to 5x 3 over 2 minus 9x plus 11. When we differentiate, it becomes dy dx, so multiply by the whole power. So 3 over 2 times 5 is equal to 15 over 2. And then reduce power by 1, so 3 over 2 minus 1 is equal to half. Minus 9x will differentiate to 9, and then plus 11 will not have a result, goes to 0. And then we want to substitute in our answer so find the gradient at point P. At point P, x is equal to 4, so substitute x equals 4 in. So dy dx is equal to 15 over 2 times 4 to the power of 0.5 minus 9, and that's equal to 6. So we know our dy dx equal to 6. Our next step then is we've got the tangent, so m is equal to dy dx. So we know that m is equal to dy dx, which is equal to 6, and therefore we can use y equals mx plus c. And we know that the line is travelling through point P because it tells us a tangent at point P. So we're going to plug in x equals 4 and y is equal to 15. Substituting that in, you get 15 is equal to 6 times 4 plus c. So that's going to be 15 is equal to 24 plus c. So then 15 minus 24 is equal to minus 9. So c equals minus 9. So from here we've got our curve is going to be equal to y is equal to 6x minus 9. So that tells us our number 3. Then number 4, we're going to find out where it crosses the x-axis. That's when we plug in y equals 0. So y is equal to 0, 0 is equal to 6x minus 9. Then we arrange 9 is equal to 6x, 9 over 6 is equal to x, so 9 over 6 is equal to 3 over 2. So we know that at this point here it's going to equal 3 over 2. Okay, so the next thing then, we've said that we're going to integrate, so we're going to find what area 3 is first, which is this small area here. Now, there's two ways you can go about this. You can integrate it, so you can integrate the curve. So the way, when you would integrate this, you'd integrate from 0, because it's just in the y-axis and x-axis all the way through to 3 over 2. So you would do 0, 3 over 2, 6x minus 9 dx. However, an alternative one is that it is a right angled triangle, and we know that it must touch the, we know that c is minus 9, so we know it crosses the y-axis at minus 9. So we can find the area of the curve simply by just treating this as a triangle, right angled triangle, which is just going to be, so we can rewrite it as 0, 3 over 2, and then 9, and so it's going to be a half times 3 over 2 times 9. And then plugging in your numbers is equal to 27 over 4. So we know that the area, this little area here, area 3, is equal to 27 over 4. Again, you can pop that here, so 27 over 4. We also need to find the area between our straight line between 3 over 2 and 4. So we're now going to integrate, or you don't have to integrate again, you can treat this as a right angled triangle. We know that this must be 15, and this is 4 minus 3 over 2, which is 5 over 2. Again, this will save you some time in the exam. You don't have to integrate every single time. You can just use useful shortcuts if you need to. So from here, if we were to do that one, it's half times 5 over 2 times 15, which is equal to times 15, which is equal to 75 over 4. So we can see here we've got a shortcut. Again, if you wanted to, you can test this on your calculator. So you could integrate your straight line. So again, your straight line is 6x minus 9. So 6x minus 9 between 3 over 2 and 4. But you should get the same answer here, 75 over 4. So then the last step is we need to combine our areas. You can do this all in one if you wanted to, or you could do it separately. So here the area under the curve that we found was 36. So we're going to do 36 minus 75 over 4, which gives you an answer of 69 over 4. And then we want to add on our small area that we found here. So that is going to be 27 over 4. So we're going to do 69 over 4 plus 27 over 4. So 69 over 4 plus 27 over 4, and that gives you an answer of 24. So adding those last two areas, that's the basically the shaded regions from the top and below, 1 and 3, you get your answer of 24. And that's the end of this question. This next question is a very tricky question because it requires you to really think about the shape. There are multiple ways of doing it. So you can, so just to run through some of the quick ways of doing this, you can first of all find where you can find this shape here. It looks like a square, but it's not actually a square, I don't think. I think it's a rectangle, so you can find the area of that rectangle. You can then integrate under the curve between these 2 points. So integrate under that, and then so you would integrate under that one, subtract away. So you'd also need to find what this shape is here, and then you could subtract that. So you could subtract that away, and then that would give you all of these. And then once you find the area of all of those, add your area of your quadrilateral, so your rectangle probably, and then you would have. Then you could find it that way. So that's a perfectly good way. I'm going to show a different way of doing it because it's slightly faster. But if you don't get this the first time, you can't see this method, then you could use that method that I've just shown as well. So this one is very symmetrical in terms of the way that the shapes are set up. You always try to be, looks like it's symmetrical, it's not quite symmetrical actually. So what we've got here is we've got a shape that looks like this here, and this is actually repeated all the way around. So I'll show you the ones between A, B, C. So this one, the red and the blue, that's all the same shape. And you can see that this is repeated all the way around. So you've actually got 8 shapes that look like the red shape. So 1, 2, 3, 4, 5, 6, 7, 8. So what we can do is if you can find the area of one of these, you can multiply this by 8 and you'd get your answer. So the first thing we want to do is we want to find out, well, what is our C point here? So we've got our curve y equals minus 3, 2x squared. So that curve here is going to be this, whatever this curve is here. So first of all, and we also have the line y equals x minus, so y equals x minus x is this one, and y equals x is this one. So first of all, to find what c is the point where y equals x is equal to the curve. So we know that at c, y equals x, y equals 3 minus 2x squared meet, so therefore x is equal to 3 minus 2x squared. Then from here we could rearrange, so it's 2x squared plus x minus 3 is equal to 0. Again, you don't need to show like anything to the polynomial. You can solve this straight away in the calculator. So go to menu, equations, polynomials, and then plug in 2x squared plus x squared minus 3. We get two values. The first one is x is equal to 1. The second one is x is equal to minus 3 over 2. This step you'll have to do for all of them. So the next one, y equals minus x, is going to be here. That's your minus 3 over 2. And again, that shows that it's not a rectangle. It's not a square, it's a rectangle. Because this a would also be at a point minus 3 over 2. But we don't need to worry about that here. The next step what we can do is we can then integrate under the curve. So we know that this curve here, so let me just rub some of this out now. So we know at that point this is going to be 1. So we're going to integrate underneath this curve, and that's going to find all of this. So we integrate under the curve, we find all of those values at that point below at c and below. So that's going to be the integral of 0 to 1 of 3 minus 2x squared. From here we can raise power by 1, so 3x, and then 2x cubed, and divide by the new power between 1 and 0. And from here actually we can just sub in 1, so it's actually just going to be 3 minus 2 over 3, because 1 cubed is 1, and that's going to leave you with an answer of 7 over 3. Again, you don't need to do mental maths here, you can use your calculator. So we know that the area under the curve is 7 over 3. But the next thing we've got to think about is that actually when we're doing our shape, so it's very easy just to go there and think, okay, that's everything I need, times that by 8. But what you need to remember is that the shape that we've drawn is this shape here, and that does not include this part here underneath the triangle. So we actually, next step now is to find what the area under that triangle is. So to find the area under that triangle, we're going to do the following, which is to subtract it away. So we need to find the area. Well, we know, so y equals x. So this, actually this point here, if it's y equals x, we know that that's going to be 1, 1. So we can know that this must be a right angled triangle here of x1, y1. And we can then find the area using half times 1 times 1, which is equal to a half. So we're going to subtract that away from 7 over 3. So 7 over 3 minus a half is equal to 11 over 6. And that's going to be our area of the shape that's, so our, not the crossed out section, but the clear one surrounded here. So our area 1. And we've got 8 of those, so we're going to go round and we're going to multiply that by 8. So it's going to be our area 1 times by 8, so it's going to be 11 over 6 times 8. And that gives a total area of 44 over 3. And that is your answer to this question. The next question we have, question 8. The diagram shows part of the graph y equals 2x to the power 1 over 3 minus 7x to the power 7 minus 7 divided by x to the power 1 over 3. The shaded region is enclosed by the lines x equals a and x equals a. If we know that the shaded region is 45 square units, find the value of a. So for this one, we can start off. Let's write out what we know. So if we do the integral, we know that 8 is going to be our bottom one, a is going to be our top. And it's going to integrate the curve 2x 1 over 3. And I'm going to rewrite this one, try and rewrite it early on if you can, unless you're very confident with indices and integrating, but this is x to the power of minus 1 over 3 because it's in the denominator. So we know that if we integrate this area, if we integrate this integral, we get a result because the area is going to be 45. So what we can now do is, our next step then is just to actually integrate and go through, because it's just going to be it's going to be an algebraic puzzle. So here we're going to integrate our answer first. So it's going to be raise the power by 1, so 2x 4 over 3 divided by 4 over 3 minus 7x, and then it's going to be minus 1 over 3 plus 1, which is 2 over 3, so 7x 2 over 3, and then we divide that by 2 over 3, and that's going to be between a and 8. From here we can tidy this up, so 2 divided by, so again there's no need to mental maths work this out, although it should be straightforward, but it's going to be 3 over 2, so it's 3 over 2x to the power 4 over 3, minus, and then again we need to plug in the next one, so it's going to be 7 over 2 over 3, so it's going to minus 21 over 2x to the power of 2 over 3 between a and 8. So we've got to this stage now, the next step, and we know that this is equal to 45. So now we're going to substitute in our values, so we're going to get 45 is equal to 3 over 2a 4 over 3 minus 21 over 2a 2 over 3, and then we're going to subtract that by 3 over 2 8 4 over 3 minus 21 over 2 8 2 over 3. First things first is we're going to get rid of all this one here, because this is looks difficult, but it's just a number in the end, so we can define that and we can move it over to the left hand side. So first of all, plug this into your calculator. So 3 over 2 8 to the power 4 over 3 minus 21 over 2 8 to the power of 2 over 3, and plugging that into our calculator gives us a sort of minus 18. It's going to be 3 over 2 a 4 over 3 minus 21 over 2 a 2 over 3 minus 18. So from this result here, this is going to be a plus, so it will become plus 18, and then we can subtract that to the other side to get 45 minus 18 is equal to 27. So it's going to be 27 is equal to 3 over 2a to the power of 4 over 3 minus 21 over 2a to the power of 2 over 3. And then again, just try and simplify your terms when you can. So again, we've got a half here, so you can factor out a factor of 2. So again, there's ways that you can rush this question, but at this stage it's a lot of marks. You want to get all the marks, and you should have time in the exam just to take it a little bit slower here. So times both sides by 2 to get rid of the half, you get 54 equals 3a to the power 4 over 3 minus 21a 2 over 3. And then from here, we're going to take out a factor of 3. So 54 equals 3a 4 over 3 minus 7a 2 over 3. And then we're going to divide 3 by 3. So 54 over 3 is 18. So we've got 18 is equal to a 4 over 3 minus 7a 2 over 3. And then from here, we can actually take out a factor of 2 over 3. So 18 is equal to a 2 over 3. And this ends up being a squared, because when you, so if you multiply the two powers together, so 2 times 2 over 3 is 4 over 3, so if you take out a factor of 2 over 3, you're just left with a squared minus 7. And then from here, what we can do is then we've got a quadratic, and we've, so you could do this, so actually from here, I wouldn't do that because you're going to end up, you might fall down the slope of doing the wrong answer. I would actually rearrange this equation here. So minus 7a 2 over 3 minus 18 is equal to 0, and then treat this as a quadratic equation instead, where let's say u is equal to a 2 over 3, because we know u squared is equal to a 4 over 3. So it becomes u squared minus 7u minus 18 is equal to 0. And then from here you can just plug into your equation polynomial taken to be 1 minus 7 minus 18. So you get, again, you could have done this straight away, so u is equal to 9 and u is equal to minus 2. So then from here we know u is equal to a 3 over 2. It's going to be a 3 over 2 is equal to 9, or a oh sorry, not 3 over 2, 2 over 3. So a 2 over 3 is equal to 9, on a 2 over 3 is equal to minus 2. So then from here we're going to cube both answers and then square root them. So we're going to just basically flip the power over. So a is equal to 9, 3 over 2, and a is equal to minus 2, 3 over 2. Plugging those in, 9, 3 over 2 is equal to 27. And then this one is probably obvious at this stage what your answer is going to be, but you do need to show that you'll rule out the other answer. So this gives you an error. It's not possible. Again, the reason why, because of that power over half, you cannot do a negative. So it's the same as saying minus 2 cubed, which ends up being a negative number, square rooted. So this is not a real number, but you can just take your calculator error forward, and therefore we know that a can only be one answer, which is 27. And that's the end of this question. Okay, last two questions. The next one we have is 5i, find the integral of x cubed minus 6x. So this one, very straightforward integral, raise the power by 1, so it becomes x to the power 4 over 4, and then divide by the new power, then raise the power by 2, divide by 2. So raise the power by 1, divide by 2, divided by 2, which is the new power, and then we plus c. And from here, I've just tidied up your answer to make sure you get the full mark. So x to the power 4 over 4 minus 3x squared plus c. And that's your answer to 5a. Then the next question, 4 over x squared minus 1. So for this question, we're going to rewrite this one to be 4x to the power of minus 2 minus 1 dx. And then we're going to integrate it. So raise the power by 1. So minus 2 plus 1 is minus 1. Divide that by the new power, minus 1. And then that becomes minus x plus c. And again, rewrite this. So it's minus 4x to the power of minus 1 minus x plus c. And that's going to be your final answer for IIA. Then the next one shows the diagram below shows the curve 4 over x squared minus 1. The curve across the axis at 2, 0. The shaded region is bound by the curve x-axis on the lines x equals 1 and x equals 5. So this one we're going to use our answer for part IIA, but this time we're going to bring in limits to it. So it's going to be, so first of all, the limits that we choose. So it's very tempting to go, oh, we can just substitute our value in between 1 and 5 of 4x to the power of minus 2 minus x, and you get your answer straight away. But that is wrong, because you have to remember that we want an area, so that's going to be a positive answer. If you plug this in directly, you'll get a positive and a negative, and the calculation that you'll do will take both, will not distinguish between a positive and negative, i.e. it doesn't know that some of your answer is negative and therefore doesn't account for it. So therefore you get, like, so for example, if this was 2, this would be minus 4, for example. Rather than giving you an area of 6, which gives you the total shaded region, it will give you an answer equal to negative 2, because all it's done is just put the numbers into the integrals and solved it. So here you have to split your integral up. So whenever you have anything crossing the axes, you've got to split the limit, do two separate integrals. So the first integral we're going to do is between 1 and 2 of 4x to the power of minus 2. It should be minus 1, sorry. And so that's our first one. And then our second one we're going to do is between 2 and 5, 4x to the power of minus 2, minus 1. So we already know the result for this. It's going to be minus 4x to the power of minus 1 minus x between 2 and 1. And this is going to be minus 4x to the power of minus 1 minus x between 2 and 5. So plugging this in is going to be minus 4 times 2 to the power of minus 1 minus 2, subtract minus 4 times 1 to the power of minus 1 minus 1. Again, plugging this in, you're going to get minus 4, 2 to the power of minus 1 minus 2 gives you negative 4, and then that's going to be minus 4. So minus 4 minus 1, which is equal to minus 5. So it's minus 4 minus 5, which is equal to 1. So your first answer here is equal to 1. And then the next step we've got is minus 4x to the power of minus 1 minus x. So between 5 and 2, So it's going to be minus 4, 5 to the power of minus 1, minus 5, subtract, and we already know this one, so it's going to be minus 4, 2 to the power of minus 1, minus 2. So first of all, we don't know, haven't calculated the one with the 5, so it's minus 4, 5 to the power of minus 1, minus 5, which is equal to minus 29 over 5. Then the second step, we already know that this part here is minus 4, so it's going to be minus 4. So it's going to be minus 29 over 5 plus 4, which is equal to minus 9 over 5. So from here, we need to add this to our original 1. So we know that this is equal to 1. This is minus 9 over 5, so our area is equal to 1 plus 9 over 5. So 1 plus 9 over 5 is equal to 14 over 5, which is 2.8. And that's your final answer for this question. Okay, the last question we're going through is this question involving a circle and a parabola. The circle with centre 0 and radius 2 meets the parabola y equals 1 over root 3, 4 minus x squared at points P and Q as shown in the diagram. Verify that the coordinates of Q are 1 and root 3. Okay, so first things first, define what the circle is. So remember that the circle has a general equation of x minus a squared plus y minus b squared is equal to r squared. We know that the centre is 0 at the origin, which is 0, 0. So we know a is equal to 0 and b is equal to 0. And we're told that r is equal to 2. So x minus 0 is just going to be, it's all squared, is equal to x squared. So it's going to be x squared plus y squared is equal to 4. And it says verify the points coordinates of Q. So this is a key thing. It's only 3 marks. You do not need to substitute in your parabola into this equation. It's a common mistake to make. The first time I went through this question I did the same thing, but that is a long process to do. The key thing here is you do not need to do that. All you need to do is just substitute in your values that you have. So you've got x equals 1. So when you have x equals 1, it's going to be 1 squared plus y squared is equal to 4. So y squared is equal to 4 minus 1 squared, which is y squared is equal to 3, and therefore y is equal to root 3, or plus or minus root 3. One of those values is root 3. And then, so because the circle is obviously going to repeat somewhere down here. And then the next thing is then test your parabola. So y is equal to 1 over root 3, 4 minus x, which is 1 squared. And then so we plug it in, so y is equal to 4 minus 1 squared, which is 3, over root 3, and so that gives you 4 minus 1 squared when x is equal to 1. Yes, so we substitute that in. So that's going to be 1 over root 3, 4 minus 1 squared, which gives you a result of root 3. Oh yeah, sorry, so it does equal, sorry, so it's going to be 3 over root 3, and then we times root 3, so we get 3 root 3 over 3, which is equal to root 3, but of course you can just plug that directly into your calculator. So here you have verified it. There is a longer method. You could do y squared, you can then substitute that in and then prove it that way, but you don't need to go to that step. So then the next step is to find the exact area of the shaded region enclosed by the arc PQ of the circle and the parabola. So in this case here, we want to find a point. So what I'm thinking, so how am I approaching this question? So the way that I'm approaching this question is I need to find the exact area of the region shaded by the region, so I need to integrate under the curve. So I can do 2 things for the area. So I can find I know how to find the area under the curve with integration, but integration with x squared plus y squared is beyond the level of the course. But what I do know is I can find arc length, and arc length here is going to be so remember that the area of an arc is equal to half r squared theta. And so I can make an arc. I know that this is going to be 2, and I need to find, and I know that this is at the point 1 and root 3. And if this has a radius of 2, this is also going to be at 2. So that's going to be at 0, 2. So that's going to be 2 here, and then the arc length is r theta. Oh, I don't know. I don't know. What do you want me to do? N be the point 1, 0. Fucking hell. I got close. Okay. Right. Okay, stop. So the 1 over 16 minus 8x squared over 4 plus x squared equal to 4. So b plus 16 over 3 minus 4. 4 over 3. Hello, and okay, the last question is, we have a circle with centers of the origin, radius 2 means the parabola y equals 1 over root 3, 4 minus x squared at points P and Q are shown in the diagram. Verify the coordinates of Q are 1 and root 3. So with the verify, it's very important to realize you don't need to do the long algebraic proof for this. All you need to do is show that those points, basically the point Q is on the curve C, is on the circle, and that point Q is also on the curve 4 minus x squared. So from here, we can go ahead and first of all find the equation of the circle. The equation of the circle is x minus a squared plus y minus b squared is equal to r squared. But we know that the centre is the origin, which is 0, 0, so a is 0, b is equal to 0, r and r is equal to 2. X minus 0 squared is just going to be x squared, so it's x squared plus y squared is equal to 4. And from here we can plug in points P and Q, so we can verify it's 1 and root 3. So if we plug in, for example, x is equal to 1, we get 1 squared plus y squared equals 4. Move 1 squared to the other side, you can get y squared equals 4 minus 1 squared, which is y squared equals 4 minus 1, which is y is equal to root 3, well, plus or minus root 3, but we know that the q will take part in the positive root 3. And the next one we have is y, the parabola, so that's going to be y is equal to 1 over root 3, 4 minus x squared. Plug in 1, we get 1 over root 3, 4 minus 1 squared. Again, you can just plug this straight in the calculator, it'll give you the correct result. 4 minus 1 squared is 3 over root 3, and if you rationalise this, this ends up as 3 root 3 over 3, which is root 3, and which gives you a y value, and that is enough to verify those coordinates. I find the exact area of the shaded region enclosed by the arc PQ of the circle and the parabola. This one's quite a tricky one because there's two areas which are quite difficult, and the first one is the assumptions you can make here regarding the parabola. So first of all, let's integrate this parabola y equals 1 over root 3, 4 minus x squared. One thing to note here is that this is going to be your stationary point at x equals 0. The way you can spot this is because it has no x term here, so it just goes up and down, and it's up and down the graph, so it's just going to be 4 minus x squared. It's a minus x squared graph that's been translated 4 upwards and then stretched in the y by 1 over root 3. So in that case here, the y stationary point stays on the y-axis, but it has just been stretched away. That's very important because that means that we can assume that this is symmetrical, and therefore that this q here is going to be 1, and this p here is going to be minus 1. So the reason why that's very important is therefore we can go ahead and integrate, and it makes it very easy for us to integrate, so it's just 1, or much easier than it is. So 1 over root 3, 4 minus x squared. Whenever we have an integral with a constant in front, I pull it out because it makes it easier. So it's 1 over root 3, 1 over minus 1, 4 minus x squared. Then we integrate. It becomes 1 over root 3, and then 4x minus x cubed over 3 between 1 and minus 1. And then from here we can substitute that in, so it's 1 over root 3, 4 times 1 minus 1 cubed over 3. Then we're going to subtract, so this is all subtract 4 times minus 1 minus 1 cubed over 3. And then just plug this in, so it's going to be 4, so it's going to be 4 minus 1 cubed, which is equal to 11 over 3. So 1 over 3 cubed, 1 cubed over 3, and then the next one is 4 times minus 1 minus, and then bracket again, minus 1 cubed over 3, which is equal to minus 11 over 3, so it's just going to be 11 over 3 times 2, or plus 11 over 3, so 22 over 3, but remember that we also need to multiply this by 1 over root 3, so times this by 1 over root 3, that gives you an answer equal to 22 root 3 over 9, and that is your first answer. So that's the total area under the curve. But this bit has an issue in terms of we now need to find the area under the circle because we don't know. Okay, so the next step here is we've got so we know we've got a triangle between 0 and 1, and we know that this is going to be at root 3 in the y, and what essentially we've done is we split in our area of our circle into 3 segments, 2 triangles, which you can find the areas of, which is just a half times base, which is 1, times a height, which is root 3. So that's going to just be root 3 over 2. So this is both root 3 over 2, and this one will be root 3 over 2 again. Again, this falls underneath the parabola at that point. And then we are going to find the area of a segment, the area of area of a sector, which is going to be a half r squared theta. We know that r must equal 2. So we need to find what the angle is here, so that's quite hard to do with just a segment, but we've got a triangle here that we can use Socoterra for. So we know that this is 1, this is root 3, so we know that tan theta is equal to opposite, which will be root 3 over 1, so this is our theta here. So plugging that in, we're going to have inverse tan of root 3, which is equal to 60. But half r squared theta is in radians, so we need to convert this into radians. So to convert that into radians, that's just going to be pi over 3. No, sorry, not pi over 3. It's going to equal... Oh, yes, sorry, so it's pi over 3, yeah. So that's equal to pi over 3 radians. So we know that this is going to be pi over 3. And so therefore we know that this one here will also be pi over 3 radians. So, and all of this together is equal to pi, so it's going to be pi minus pi over 3 minus pi over 3, which is going to equal pi over 3. So we know that this angle here is pi over 3, and we can substitute that into half r squared theta, so it's going to be half times 2 squared times pi over 3, which is equal to 4 divided by 2 times pi over 3, which is 2 over 3 pi. So to find the overall area here, we take our integral results, which was going to be 22 root 3 over 9. So 22 root 3 over 9, and then we subtract away our area of a triangle, so that's going to be 2 times root 3 over 2, and then we're going to also subtract away our half r squared theta that we've just found, which is minus 2 over 3 pi. As this is root 3 and root 3, we can simplify this a bit more, so 22 over 9 minus root 3, so or 2 root 3 over 2 if you want to plug it in directly. So you should get, sorry, 22 over 9 minus 1 is 13 over 9, so you're going to get 13 over 9 root 3 minus 2 over 3 pi. And they want it in exact form, so that is your answer to this question. And that is all the questions for this series. If you have any further questions, please let me know.